With its 16 golden observation mirrors, the James Webb Space Telescope sees more sharply and precisely into space than any telescope before it. It can see even at angles that were hidden from Hubble for the first time. We are witnessing the events shortly after the Big Bang, and we see strange points of light in the early universe, mysterious gaps in the cosmic background radiation, and black holes that are so huge that they must have existed before the Big Bang or come from another universe. The James Webb Space Telescope continues to make groundbreaking discoveries that challenge our understanding of the cosmos. Now that the first real evidence of another universe has been confirmed, shocking new objects may prove the existence of other dimensions and worlds at NASA. It remains unclear what the implications of the latest discoveries will be. Immediately following the Large Bag, one unexpectedly completed galaxy's one of the biggest surprises of the JWST was the discovery of fully formed galaxies at a time, when according to previous models, they should have been chaotic gas clouds according to the standard model of cosmology. It took several 100 million years for the first stable galaxies to form from the dense, hot plasma of the early universe. But the JWST has found dozens of massive ordered galaxies that already existed 300 to 400 million years after the Big Bang. Not only is the mere existence of these galaxies a miracle, but they also exhibit completely unexpected properties. These galaxies are not only much older, but also much more structured than the cosmological model. Allows some researchers therefore speculate that these structures could be material remnants from an earlier universe. This discovery gives impetus to a theory proposed by British researcher Sir Roger Penrose. Penrose published his idea of the conformal cyclic cosmology, or CCC for short. Back in 2015, according to this, our universe is just one in an uncountable series. When one universe dies, a new one is born which expands and develops until it reaches an end, collapses and gives birth to a new universe. It may be that not all structures are lost at the end of the universe. Certain density fluctuations or even complete structures of matter could be transferred to the new universe. This would explain why galaxies in our universe have evolved much faster than researchers originally thought. 2 enigmatic Hawking points. Although the JWST was not designed to map the background radiation, researchers have now used the new telescope to solve an old mystery. They used the JWST's extraordinary sensitivity and infrared vision to examine irregularities in the background radiation. The keen eye of the telescope should reveal structures in the early universe that shouldn't be there, such as colder regions and larger gaps irregularities. The cosmic background radiation is the earliest light we can observe, and the JWST will look exactly where these structures came from. The afterglow of the Big Bang, which has been present in the universe for about 13 billion years, has been thoroughly mapped by satellites like COB-WMAP and Planck. Among the most unexpected anomalies are circular temperature patterns that defy the standard model of cosmology. Once more, researcher Sir Roger Penrose thinks he has found an explanation for these patterns. 2 Hawking radiation. According to his theory of conformal cyclic cosmology, all black holes gradually vanish through Hawking radiation at the end of each cycle, leaving behind a nearly empty space-time that serves as the foundation for a new universe. If this theory is accurate, then Hawking points in the CMB may be the final remnants of a long-gone universe. If Penrose is correct, it would completely upend our worldview, as the Big Bang would not be the beginning of everything but, rather just a phase in a much larger eternal cycle of universes. 3 supermassive black holes appear to be remnants of an earlier universe. With its deep dives into the universe's past, the James Webb Space Telescope has discovered evidence that massive black holes existed before the Big Bang, which could prove the existence of an earlier universe, in addition to the mysterious points in the cosmic background radiation. Compared to highly developed galaxies, this is actually equally difficult. Additionally, it typically takes billions of years for very huge black holes to reach such magnitude. The JWST has found very enormous black holes that must have existed only a few 100 million years after the Big Bang. Normally, black holes are formed by exploding stars or by the gradual accretion of gas over millions or even billions of years. If Roger Penrose's theory is right and our universe is cyclical, then some of these enormous black holes could have survived the transition between two universes. In the last stages of an old universe, when only black holes remain, some extremely massive specimens could have survived. This discovery contradicts previous models because it should be impossible for such huge objects to form in such a short period of time. The fact that these black holes have completely formed accretion disks, which indicates that they are actively consuming matter, is another indication that they are ancient and not young. However, how can this be the case in a universe that should have very few stars and matter at this apo? Another alternative is that we are looking at the interface of several worlds in this apo. In that case, it would be about an encounter between multiple universes with varying ages, as well as a predecessor and a successor universe. The enigmatic cold area is thought to be a clue to another world, and experts believe that universes from various dimensions might overlap geographically in time and space. Here, let's examine the cosmic background radiation once again. Another crucial hint might be the so-called chilly spot. Although slight temperature variations are typical in cosmic background radiation, which are caused by quantum fluctuations of the early universe, the area known as the cold spot is abnormally large and too cold to be explained by such fluctuations. This vast region, which is colder than calculations of the standard model of cosmology allow, could be a point of contact with another universe. Although scientists have been looking for an answer for a long time, no conventional theory can adequately account for this anomaly. One of the most intriguing hypotheses is that this cold spot could be the first direct indication of a collision with another universe. This would confirm the theory of the multiverse, which states that our universe does not exist in isolation, but is part of a much larger cosmic web in which there may be many other universes with their own natural laws and physical quantities. It's conceivable that there are universes in which time runs backwards, those that consist only of antimatter, or universes in which matter, as we know it, does not exist at all. There could also be an exact double of our world if our universe intersected or even partially overlapped with another, which could be so-called Hawking points, which are the remains of supermassive black holes that existed in a previous universe and vanished at its end due universe. In the early days, this interaction could leave traces in the cosmic background. Radiation scientists are now using the unique power of the James Webb Space Telescope to study extremely distant galaxies and structures that could lie in the cold spot if the JWST detects unusual matter, distributions, strange light patterns, or even signs of unknown physics there. It could be a strong indication that the cold spot was actually caused by interaction with an alien. Universe 5 JWST provides further evidence of another universe and verifies the issue with the universe's expansion. Did you know that the cosmological principle, which holds that the world is homogeneous and isotropic on a vast scale, has been supported by decades of evidence suggesting that the cosmos may not be expanding evenly as initially believed? According to this, it should appear and behave the same everywhere when viewed on a physical scale, but recent measurements challenge this idea. They show that the universe is expanding at different rates in different places, which calls into question the conventional model of cosmology and may also suggest some bizarre alternative theories. The first theory holds that our world interacts with another universe, causing its movement to be regionally warped. The second theory holds that we live in a bubble universe, where expansion inside each bubble is always somewhat different due to the application of slightly different rules. The so-called Hubble tension is one of the greatest unsolved mysteries in modern cosmology. The JWST was used immediately after its launch to retake the measurements. There was a slight chance that the precursor telescopes were incorrect, but that is not the case. The JWST confirmed the Hubble tension once more, leaving scientists even more perplexed and mysterious than the tension itself. The different expansion was demonstrated by discrepancies in the so-called Hubble constant, which indicates how quickly the universe is expanding, depending on the measurement method. The Planck satellite data indicate a slower expansion rate of 67 km per megapark, while measurements of supernovae yield a value of 73 km/second per megapark. If it turns out that our universe is not impacted everywhere, scientific exploration and calculation from a distance will be nearly impossible, and researchers would have to give up on their hopes of deciphering the universe through theories and formulas. Regional differences in the expansion rate. Some observations indicate that some areas of the universe are expanding faster or slower than others. 6 oddly luminous, early universe objects, a riddle of the cosmos, imagine that researchers use. The JWST to observe details of the early universe. Suddenly extremely bright objects appeared where there shouldn't be much, and they only existed a few 100 million years after the Big Bang. These mysterious light sources are much brighter than should be possible for this APO and present astronomers, with another major problem: the spots appear too young, too massive, and too bright to be normal galaxies or stars. But what could they be? Then one obvious explanation would be that they are early quasars. These would be supermassive black holes made to glow by huge amounts of accumulating matter. But here too, there is a problem. According to previous models, the formation of such gigantic black holes takes hundreds of millions of years. But some of these bright objects already existed, 300 to 400 million years after the Big Bang. The question also remains for these objects: how could they accumulate such a mass in such a short time? Some researchers speculate that these could be a completely new type of celestial body, so-called dark stars or pre-galactic objects, which are possibly relics of a previously unknown physics. Join the channel immediately, as we are always releasing new and fascinating films.